Like a jigsaw puzzle, the rules of maths can be used with the known information to identify any parts of the picture that are missing. The jigsaw is solved by comparing each part of the puzzle. If you know how to fit the pieces together, you can identify what the missing parts look like. In maths, concepts can be combined to form strategy for solving common problems. In this tutorial, you will learn the divide and conquer strategy to solve ratio problems. This strategy consists of division, the number one, and multiplication. Ratios are made from two or more related information items. Components of a ratio are identified wherever an information item is considered to be the equivalent of another. The example question asks, if 4 squares weigh 12 kilograms, how much do 7 squares weigh? The first step is to identify the facts given in the question. Then use these facts to write a maths description of the question. Because we are writing the description as a ratio, the equal sign should be changed to a colon. Nothing changes in the meaning. This just makes it clear to anyone reading the maths that the description is a ratio and not something else such as algebra. With the maths description now in place, we are able to modify the facts to suit the problem. The basic tools of maths for working with numbers are addition, subtraction, multiplication, and division. An option to solve the problem is to add 3 squares to all components, giving a total of 7 squares. The problem with this is that squares now appear in both parts of the ratio, leaving us without a clean measurement for what 7 squares weigh. Because of this, addition is not a valid option for the strategy. Similarly, the use of subtraction can be problematic. While we could take away squares from this side, we can't take away squares from this side. This means that subtraction is also not an option. The remaining options are division and multiplication. Sometimes the problem can be directly multiplied or divided to become the target amount, but this only works if the target amount, in this case 7, is a multiple of the original amount, in this case 4. The number grid you can see will be used to visually show multiplication. Each of the highlighted numbers are achievable outcomes from multiplying 4. Multiplied by 1, the result is 4. Multiplied by 2, the result is 8. Multiplied by 3, the result is 12, and so on. With the target, 7, not being a multiple of the original 4, there is a need to change the original number so that it can be a multiple to become the target number. Let's look at numbers we can change the original amount to. Changing to 3 provides more visible outcomes, but none of them are the target number 7. Changing to 2 gives even more possible outcomes, but still, none of them are the target number 7. Finally, changing to 1 does provide the target number 7 as a possible outcome of multiplication. Another important observation that should be clear is that every number is highlighted. This means that if you change your original amount, in this case 4, to 1, you can guarantee to be able to multiply the result into any target number. Fortunately, any number can be scaled down to 1 by dividing it by itself. Let's use some numbers with Mathscatter to see how this works. The first example we see is 5 divided by 5. We select all 5 parts, 1, 2, 3, 4, 5. We then select to split these parts into 5 groups. Group 1, Group 2, Group 3, Group 4, Group 5. There is now one of each of the parts inside every group. Let's try another number to prove that the same result is delivered. This time we use 3 divided by 3. We select all 3 parts, 1, 2, 3. We then select to split these parts into 3 groups. Group 1, Group 2, Group 3. Again, there is now one of each of the parts inside every group. With the knowledge of these tactics, we now have everything required to solve the problem. We can choose to scale either the number of squares or the equivalent weight measurement to 1. The subject of the question is the number of squares, which we must scale to the target amount, 7. Our initial focus is to scale the amount of squares down to 1. Like with algebra, actions performed on the part of the ratio need to be repeated against all parts of the ratio. 4 divided by 4 equals 1. 12 kilograms divided by 4 gives us 3 kilograms. The ratio description now tells us that 1 square is worth 3 kilograms. The final step is to use multiplication to scale the question subject to become the target amount, in this case 7. 1 multiplied by any number is always the same number it is multiplied by. So to get 7, we multiply 1 by 7. Because we multiplied the squares component by 7, we must also multiply the other ratio component by 7, resulting in 21 kilograms. We have now solved the problem by using maths actions to prove the weight of 7 squares. A quick summary of how the divide and conquer strategy is applied to solving ratio problems. Step 1. The ratio description is defined. Step 2. Division is used to scale the entire ratio against the question subject, providing measurements relative to 1 unit of the question subject. Step 3. Multiplication is used to scale the entire ratio against the target amount, resulting in the answer to the question.